So, hi everyone. Today we will be exploring the very new model that is SAM V2 Segment Anything model version 2, and this has been released by Meta. Earlier we had SAM V1 version 1. Now we have SAM version 2, which is having a lot more capabilities than the previous version, and it is capable of segmenting anything from the image as well as from the videos. So let's get started. For this, we will be using Google Colab free version, and we'll be using the GPU runtime. And the GPU runtime that we'll be using is T4. So you can just go and change the runtime over here and change it to T4 GPU, which is free to use. For exploring the SAM version 2, I would suggest you to just Google SAM V2 Meta, and here is the website where you can explore the model. You can even download the model weights or the checkpoints, we can say. As you can see in the video, it is trying to segment particular things in the video and the image, whatever you want to select. If you go down, there are multiple examples of how SAM V2 is segmenting the objects in the images and videos. If you want to explore more, you can read out the research paper as well, and you can find it down the line in the same page over here. Read the research paper. Here you have the abstract, and you can download the paper as well. I'll create another video for explanation of the research paper. For now, we'll just explore the SAM version 2. Also, if you want to explore the GitHub repo, you can just search for SAM v2 GitHub, and you will find this particular link, that is Facebook research segment anything 2. This is the official repository that you can go and explore. You have the readme file, which explains a lot number of things in here, how the segmentation works for the image as well as for the videos. So you have few examples, the screenshots over here, how exactly it is segmenting the images, and you have the go to code as well over here, which you can use for segmenting the image or videos. You have the example notebooks, you can explore more, and the models that currently SAM version 2 is having. It is having the tiny, small, the base plus, and the large version. And you can find the description over here in terms of size, the speed of the model for segmenting the image or video, and similar kind of parameters. You can explore more in the research paper as well. So let's dive into the code. First of all, we'll just check our NVIDIA SMI. So we have T4 GPU, and the CUDA version is 12.2. Fair enough. Now, the very first thing that we'll do is we'll just get our home directory. That is in Google Colab, it is slash content. Next, we'll clone out this particular repository that I just showcased, Facebook research segment anything to, and then we'll cd into that particular directory once it is cloned, and we'll install the requirements. So we are doing pip install -c dot -q. So this particular command, having the -e flag, that is used for installing all the requirements in editable mode. So what happens is, when you install the requirements in editable mode, then it basically installs everything for that particular repository, or the package into the editable mode. And whenever you want to change something, it basically uh, changes everything what you want to change on the go. In a regular mode, what happens is, whenever you do the pip install, the package gets installed in site packages, but here it does not happen like that. It installs it within the root folder, or whatever directory that you have cd'd into. So let's run it. All right, I already cloned that particular repo, so it is showing me It already exists. Let me just showcase it to you. So here we have segment anything 2. Now we'll be installing the supervision as well as Jupyter VBox widget. So supervision is basically used for performing different kinds of operations with images and the videos. So it is having a lot more utilities for doing all that. So we'll be using it a lot in further cells. I already installed it. So I guess it should not be having any issue. All right. Now we are just pulling out the weights or the checkpoints, I can say, for SAM2 version. So I'm pulling out the weights for tiny, small, base plus, and large, all of them. And you can see those checkpoints being stored in here. So you have all the versions. Next would be importing the required packages. So here we'll be using OpenCV 2. We'll be using the PyTorch version, and the version we have to use is 2.3.1 or greater than that. The base 64 NumPy supervision, as I said earlier, for performing different operations with the images and videos. And now we have the imports for SAM2 repo. So we have built SAM2, SAM2 image predictor, and automatic mask generator. For now, we'll be using these three. Let's just import them. All right. Now we have the torch autocast, and the device type that we are using is CUDA because we have the NVIDIA T4 GPU with us, and the data type that we will be using will be float 16. So what happens is this code basically uses the automatic mixed precision for computing the images and videos during the deep learning process. So it basically fastens the process, the calculation process, and for this it particularly uses the quantization to float 16, reduces the precision to float 16. And here we are making the CUDA allow TensorFlow 32 equals to true, and for this we'll be using CUDNN. This is pre-installed in the environment by Colab itself. Now the next thing would be we are basically giving the checkpoint path. So we have home, that is slash content, then checkpoints, then SAM2 large, right? The config that we are using will be SAM2 1 YAML, and this particular config is being passed into the build SAM2 checkpoint. Device apply post processing will be false for now, and let me show you the config. So here we have the config with us, so we are using this particular config for now. Let's quickly run it. All right. Once it is built, then we can just perform the masking. So there is a mask generator that is defined that it as a SAM2 automatic mask generator, and we are providing the SAM2 model in here, and that is nothing but the build model that we have just created right now. Let's run this cell. All right. Now we'll just load the image, and we can get that sample image within the data. We do have a few images, and let's use this particular image, and we'll try to load this image using OpenCV2. So it is reading image in blue, green, and red BGR by default. We are converting it into RGB format because this particular mask generator that we are using over here from SAM2, it requires this particular format. So we are converting it over here, and then we are generating the masking over here. Let's run it. All right, let's go through the masking, how it looks like. All right, so it's a dictionary. It is having all the information about the mass, different mass that are being segmented within the image. So we have the area, we bounding boxes, and few other parameters, and we can make use of this for drawing the bounding boxes as well as for segmenting particular part in the image. So we have this output format. You can quickly go through it. Next we'll be visualizing the results. So what I'm doing, I'm just using supervision mask annotator and providing the color lookup index. So it will basically index all the masks and provide them the color palette. Similarly, the detections from SAM, and I'm providing the SAM results. That is nothing but this dictionary. And the annotated image would be mask annotator dot annotate, and again the copy blue, green, red, and the detections that we are generating over here. And we are plotting the image grid using supervision again. Let's do that. All right, now here you see this is our original image and this is the segmented image. So you can see different segments over here. It is basically segmenting each and every object within the image. So you can see the cat being segmented, the dog, its tongue, the building, the bag, and so on. Now let's check the segmentations. So we are just sorting the results dictionary using the area in reverse order, and we are taking the segmentation key from it, and we are trying to plot different plots over here. So it looks something like this. So all the segments, or I can say all the masks that are being plotted over here from the image, and from these masks the image basically highlights it with each different color palette over here with the index. Next, let's go through the advanced automatic mask generation option. So we have multiple options over here, and accordingly we can give the values, we can play around with it. uh, if you want to learn more about it, you can quickly go through these, what exactly each and every parameter does. For now, we'll just stick with the code, and over here, some of the values I have provided. For example, model will be SAM model, that is fixed. We have points per slide, then per batch, the threshold, the stability score threshold, the offset, etc. And descriptions for all of them, you can find it within this particular cell. I can provide you the notebook in the description. So let's run it quickly. Again, we'll generate, and now once this runs, we will annotate it and we'll check the difference. All right, it has finished running, and now we can see the difference. So here is our source image, and here we have segmented image. So you can play around with your own images. These are just the sample images. You can use your own set of images and try it out. Next, we will go with prompting with boxes. As per the scope of this video, I'll just stop here, and we'll proceed next with the bounding boxes in the second video. And in the third video, we'll be doing the segmentation in the videos instead of images. So stay tuned, and thank you so much for watching. This is my very first video on my YouTube channel. Please like it, subscribe it, and share it. Thanks a lot. Have a great day ahead.